And we are live. 1, 2, 3, 1, 2, 3. Do you hear me? I hope so. Okay, so hello everyone. We are live in our new webinar about .NET diagnostics on .NET in production. So it is important on .NET. I mean, with .NET on production. So why is and how's about that? I'm a host today, and I will just moderate the discussion with myself and Sebastian, which is a
Hello, everyone. Hi,
Minecraft.
Konrad.
Yes, hello, nice to see you. And
Yes, you too.
we will go through some hows and whys about production diagnostic, as we mentioned. So I'm super happy that we are here today. We are here to answer your questions. This is also, and I would like to see this webinar as a kind of Q&A with you. So as I invited you on chat, say hello, say from where you are, and do not hesitate to ask, to interrupt us, give us any questions. We will answer immediately, as long as we will know the answer, right? If we will not know the answer, we will find out and answer later on. So just do not be afraid to ask anything, because we would love to have a feedback from you. So we have currently we see someone from India, from England, from Ukraine. So we have almost all globe covered, and that's super nice. So without more introductions, let's say that this webinar is totally free, obviously, and we are super happy to share knowledge. And believe me, Sebastian is a real diagnostic expert and ninja about stuff that we will cover. So me watching him is always like kind of head explosion, because yep, he is going deep, and he is able to go really deep. So do not hesitate to ask him also deep things, like what is this on kernel level, for example, right?
Do not exaggerate, but let's try.
Almost. Let's try. Yes, exactly. Croatia and France. Hello, cookies.
Bonjour.
Bonjour, exactly. If we are spelling this correctly. This is all because we are currently providing something which is called .NET Diagnostic Expert course. So if you are interested in such topics, Sebastian is an author of this course. We invited him, or maybe you invited us, I don't recall exactly, but the effect is that we cooperate and we host awesome course about .NET Diagnostics, which is created by Sebastian with the help of those three mentors that you should really know from somewhere, like Kevin and Christoph, giving awesome talks about .NET Diagnostics, and Paweł Josifowicz, which is co-author of so legendary book as Windows Internals, 7th edition, as far as I remember. So we are all one family about geeks and nerds and freaks about .NET Diagnostics, and we decided to create such a course. So if you like to know something more, you can find us on .NET Diagnostics Expert.com site. We will provide a link afterwards. So just having covered this part, we would like to start the discussion, because the topic of our course, of our webinar here today, is .NET Diagnostic on Production. So whys and hows about something like that. From my perception, if Sebastian, maybe you can introduce yourself. Sorry, because I started and jumped directly into the topic of, of the webinar, but I didn't allow you to say anything. So sorry for that. If you could say something from your side also about yourself, for example.
Yeah, thanks. I will just say that I have more than 12 years of experience. I like to call myself system engineer, as I'm not only, I wasn't working only as a developer, but also sometimes in the role of a DevOps guy. So working with the system traces was also part of my responsibility. That is why I like to connect the things between application and the operating system. That always interested me, how things work internally. And I believe that many people share this interest, and we are here just because we all share this interest, and we like to know how to understand things. And that's what the whole webinar and also the course will be about. Not, of course, the main topic is troubleshooting, but we all know that it's not only about it, but also about knowing. So, and more about me, I have some projects on GitHub with which are open source, mostly diagnostics tools and a little bit of cryptography. And I also have a blog where I sometimes publish stories about different diagnostics.
Interesting stories.
Yeah, sometimes interesting, sometimes maybe a little more off topic, like some things that I met in when working with different system tools. So
right, I'm just posting the link to your blog.
Thanks, Konrad.
Just to interrupt everyone with
and just to finish,
start reading your blog posts instead of listening to you.
I'm super happy that we are starting this course, and I'm super happy that we have mentors that Konrad mentioned just a moment ago. Really great people which did a lot for the diagnostics community, as you all know. So
also not only expert, but also super nice people. So it is really like one big family. Okay, but this is too sweet. So let's start to
start
the merit.
Talking about bugs.
Exactly. Bugs, not to be too sweet. So whys and hows, and in general, obviously we have something like debugging, right? So we have debugging, and then we have some problems on productions, and we can touch and attack this problem from various ways. And as far as I remember, there is this nice 3-step process about everything, that how you can approach the problem. So you have some problem, and then you need to solve it. And Sebastian, maybe you could explain those 3 steps.
Yeah, just to cite, that's a citation actually from NDC presentation by Christoph Nassar and Kevin Goss. It's a really nice presentation. You definitely need to have a look at it. So those 3 steps are really necessary to solve a bug. So we start with identification. So first we need to gather the data, learn about the bug, what is, collect as much data as we can. Of course, too much data is also a problem, but generally it's better to have more than less. So it's good to use, if we know where the problem lies, then try the tools that can get the data for you. Then try to understand things which you saw in the logs or in the collected traces or in the memory dumps. So create a hypothesis, what could be the problem here. And then next step is to verify if this hypothesis is correct. So to check, either create a proof of concept or maybe use the application that is breaking and try to reproduce the problem and with another traces that will prove that what you just identified is correct. If it's not working, then you need to start again. So those 3 steps are necessary in almost all the troubleshooting cases, and it's nice to have them somewhere back in your head and get back to them when you are doing the troubleshooting.
Awesome. So this is the framework for solving anything, in fact, related to not only .NET, but in general. And then we can move to some more details, like what can be the tool or approach, and so on, right? So the very first thing that I have in mind when talking about issue and bug and error is debugging. So debugging is a powerful thing. Obviously, we have our local machine, we are having our code, we can attach to our process, we can attach on a trigger and attach on exceptions, for example, right? We can make a step-by-step, step into, and all this magic. So why this is not everything? Why not every problem can be solved like that?
Yeah, that's what just Konrad said is the fact that we are on our local machine and we have access to everything when we are debugging is very it's a very comforting thing, because well, we won't have it on production. And so but even when we are on our local machine and have access to everything, well, it's important to know your tool. So the debugger is, as you probably know, even the Visual Studio debugger, it has so many different windows, and even the exception settings window, which some people know, some people does not know. What is the first chance exception? How to get to this exception? It is always helpful to check the documentation of the debugger. So maybe watch some videos about Visual Studio. If you want to debug the problems, even locally, it's really worth to understand and know what you have in the tool that you're using. And in a moment, actually, just after the first slide, after the few slides, we'll have a demo when we'll be, for instance, using one of the features of Visual Studio. And of course, there will be many more of them on the next webinar that we will have and later in the course. So I really recommend checking well, even the Visual Studio documentation or the debugger that you're using. If WinDBG, then check the commands, the help.
There are some pretty powerful features that we can be even not aware of, like how to really use debugger. And the other thing is how the debugger works, right? So when I was looking to the agenda, and I know that we will cover that in course, to not only explain how to use debugging, but also how it really is working underneath. This is super nice to understand also, because sometimes, as you said, even in the beginning, it is just good to know how it is working simply. Like,
well, yeah, when you know how it's working, or how the engine works, what are the events, then you will understand what you can get from the tool. So for instance, you can expect some features, even if they are not there, you will expect that they could be there. So you might start looking for them if you know what types of events the debugger is getting. So for example, sometimes when after using WinDBG, I started looking for a feature. For instance, a good example is data breakpoints, which were in WinDBG for forever, but they were not working till the latest versions of Visual Studio in Visual Studio. So it was not possible to set a data breakpoint for the managed code until Visual Studio 2019. But in WinDBG, you could do that always. So that's one of the features that, when you know how the tool works, what's the debugger about, what the engine can do, what the processor can do, then you will know that, okay, this feature should be there. It's not, sorry. But you may find it in the documentation somewhere hidden.
Awesome. Yes, that's totally true, and I agree totally. By the way, if you see that I have only 11 slides, this is by design, because this webinar is not about theory, so we don't have many slides. It is more about demo showcase. So we will have demo. Sebastian will show us some real practice ninja debugging stuff in a few minutes. But just before jumping into it, I believe it is really now, because we have the base understanding that obviously, and probably you feel that sometimes there is a problem and you are not able to do with it anything on local development machine, because it is just not possible to reproduce it, or maybe it happens due to some very intermittent strange conditions on the production, or maybe it is just because of the huge traffic production that you just cannot reproduce on your local machine. There may be many issues with this. So debugging is super nice. We cover debugging, we are interested in debugging, but going further, so if not debugging, so then what we can do else? And here we have few, let's say, three main groups that we can imagine. The very first one would be tracing, and this is a powerful stuff. So maybe you can, Sebastian, say us a few words about tracing. How do you perceive it? And by the way, the most important thing, why we are able to use it on production.
Yeah, the first reason why we can use it on production is that it's much less invasive than debugging. And if we are using the kernel providers, for instance, then we are not touching the application in any way. So we are doing some collecting on the kernel side. That, of course, impacts the whole system, but either on Linux or on Windows, it's well known that it should not be more than 10% of the CPU time. So I think it's usually it's acceptable. And even when we are tracing using the application providers, if we choose them carefully, then tracing also shouldn't be problematic. The framework authors, framework developers put a lot of effort into making the tracing quite non-invasive, so we are safe to run it in production. And as Konrad mentioned, tracing is great for troubleshooting, but I also consider tracing great for learning. So even when you're on your local machine and not necessarily on the production, where of course the main reason is troubleshooting, but when you're on your local machine and you run the trace, you can, before going into the source code, or sometimes the source code is not available, you can learn what the application is doing. So you can learn which files it is using, or for instance, what DLL it's loading, or those kind of different things, which connections it's doing, but by just simply tracing the application next to the debugger. So, or even without the debugger. So that's a really cool technique of learning what the application is doing.
So can I rephrase that? Tracing is kind of sophisticated logging, that we have a low-level, low-overhead infrastructure for logging things like events or some small data.
Yeah, exactly. We can think of it like...
And that's the power of it, because I can run it on production without the fear of, let's say, blocking and halting the whole application, because it will just run in the low overhead, and it can run for minutes, hours, it depends probably.
Yeah.
So that's very nice. And this is the real power that I really like to use, because I see this, and I was even having all the same mindset that I would say it, developer-centric mindset, that when you have a bug, you have a debugger and you need to debug it. But after some years of experience, I have this feeling now that very often it is much faster to solve problem by just tracing it on the production, instead of trying to reproduce it on the development. So having this tracing toolbox in your hand is really, really powerful thing. That's why we cover it in our demo, like in a few minutes. And we have the very first question. Could tracing impact the performance?
Well, generally, if you yes, it can impact the performance. So it's important to know which type of tracing you use. So which tools, which techniques. So as I said, for example, if you are using the kernel providers, there's a really small chance that the impact will be noticeable. So it's quite safe to use the ETW, or on Linux BPF, or LTTNG, or perf. Those are the actually perf and BPF are the kernel engines behind the tracing. So when you are using this type of tracing, I would say that it's safe and it should not impact the performance. With .NET providers, it depends. For instance, the CPU profiling of .NET applications, when we are not using the kernel provider, could impact the performance, because when we are collecting the CLR, when it's collecting the call stacks from all the cores, CPU cores, it freezes the threads. So that's for instance a problem. Right. We also need to remember about how we are saving the traces, because if we are just collecting and we do not put a limit on the trace file, then we might run into a problem with a disk space, for instance, something that we tend to forget when we run trace for hours, for example. So. Right.
And if it is the only one disk on your system, then you have
yes,
a problem.
when you're saving to
Yeah.
C drive, then
This is kind of very exaggerated performance overhead, but I agree totally that my practice is that the overhead may be very, very small, but you should really understand what you are doing and know the tool, because there is always possibility that you will turn on too many. Like if you start to collect stack traces for every allocation in your application, and this application allocates a lot, you will see performance overhead for sure, because collecting stack traces is cost, and then multiply it by many allocations, it really introduces overhead. So again, it is really nice to know the tool that you are using, not just blindly copy paste parameters from Stack Overflow, for example. And then we have another very interesting question. So why would anybody log if, I believe it should be here, if they could trace? So the difference between logging and tracing.
I would say that logging is for knowing what's happening in the application on this normal level. So you log things, business-like. So you log things that are critical for you to know that the application is working correctly, or to log things that connect with the data that you have in the database, for example. So you have in logs some detailed information about something that you saved in your data store. So this way, if someone complains or there's a problem, you will know, at least you will have some information what the problem could be about. So I would say that log is the first triage. And the same about the system logs, actually. When we check the event viewer or the system log in our operating system, we see that it's mainly about showing the big picture of what's going on. So there are not like stack traces there. Okay, stack traces are sometimes there, but there are not. Those are not very detailed traces. They are usually on the information or upper level, so warnings, errors, just to understand if there's an issue, or if application is working correctly. So if it's performing the actions that we expect it to perform.
Right. So it is like the difference in the logging level in your tools. So by logging, you should probably understand the log level, and tracing will be somewhere around the trace level. So you can trace a lot of information, but it is just an overhead, because tracing is more about technical stuff, and logging will be probably more about the operations itself and some business related data, especially in this happy path.
Yeah, and also we usually store logs for some time. So if we were to log everything, or on the log stuff on the trace level, then our storage will suffer for sure.
Exactly. And also a good point from Sim, from Tallinn, that there is a big distinction, because we are saying tracing, but this same word is used in the distributed tracing. So I believe here I can answer, even maybe you can add something, that we are mostly concerned about the local tracing inside a single process of your application, not the distributed one, which is obviously a huge topic by itself, but it is more maybe even architectural one, not the one about diagnostic itself of the particular process. Okay, so we have this tracing. I feel it is really powerful and useful. So do you have any, maybe you can jump with some single scenario that you remind from your practical diagnostic life when it was useful?
Yeah, I recall one which I really enjoyed is a bad word here, but
you can enjoy bugs and solving them, right?
Yeah, but it was a really interesting, challenging one. I remember when we had the bug report that I received was that we had in the production, not in the production. It was in the production actually. We had a service which, when after when a Windows service, when we were starting it, it never started on the first run, but you needed to start, wait a moment, and then it was stopping, and then started again, and it suddenly was working. So, and this bug was...
Sounds like good DevOps issue.
Yeah.
Write a script.
And this bug actually lasted for, I think, months, and people get used to the fact that they need to start this service twice. But at some point in time, I finally had time to look at it, and it was, I recall that the service, the main service, so the one that we needed to start twice, was using RabbitMQ, and RabbitMQ had, I'm not sure how it works now, but at that time it had, when it was running on Linux, the .NET client, on Windows, the .NET client had some performance counters. So it was reporting some performance data that we can watch in the performance monitor. And interestingly, on the server machine, when the application was starting, quite often actually the performance counter service, so the other Windows service, which is responsible for collecting the performance counter data and then allowing to query them, was stopped. And when RabbitMQ tried to run it, then this server, as it was stopped, it was not working. And the funny thing about the API that performance counter use is that the performance counter tried to start this service, but Windows has a lock on the sort of a mutex on maybe it's mutex or critical section. I don't remember exactly, but there is a lock on the Windows service initiation code. So it's not possible that two different Windows services are starting at the same time. So when I collected the trace with Purview, I remember, and I had the thread time check on it, I noticed that there is this switch that after the service timeouts, so the RabbitMQ service was timeouting, the other service immediately was started, so that the thread was yielded by the operating system. And this way, I somehow connected those two. Of course, I didn't have the exact address of the log object, as it was only a trace. But by just looking at the call stack, I was able to identify the problem. So by adding the dependency on the RabbitMQ service, so on our service, by adding a dependency that we need to have the performance counter service started before starting the RabbitMQ service, everything started to working fine. So that was one of the interesting examples that I ran into production.
So the tracing at its maximum being used here to solve the issue. I remember a very similar issue with Windows service not being able to start due to some lack of some writes, and it was also very, very hard to track without tracing because it was only on this particular machine, closed somewhere, so nothing really simply to reproduce. Awesome. And regarding tracing, I know that you would like to show us one of the tools that shows them on the operating system level, like process monitor, like one of the tools, because I can just say that there are various tools for that, like process monitor, Purview, Dotnet trace. We will cover them during the demo, but maybe you can show us a process monitor as a also another powerful thing to.
Yeah. If Konrad can give me
give you the screen now, right?
Okay, so Procmon is one of the sysinternals tools. Almost on all the diagnostics, the presentations about diagnostics, I feel I need to mention it. It's really great, and it's very simple to use.
And it is free, right?
Yes, it is free. It is free. It's not open source, unfortunately. I hope one day it will be, but it is free. And you simply click the icon for tracing, and immediately the events start happening. The difference between Procmon and other tools that I will mention in a moment is that Procmon for those system traces, so for file I/O, registry I/O, it is using a driver. So not really the kernel provider, but it has its own driver assigned by Microsoft. So when it's running, it loads this driver into the operating system, and we can actually find this driver. But it also has a very interesting filtering. And just as a simple example, we will save this file, this notepad file, but to well, maybe to temp the webinar, and just a test file. And if I stop the trace, okay, I didn't put the the modal window. Okay, now we have the trace stopped. And if we change, for example, one of the filters is category. If we set it to right, we'll find all the events that happened during the trace that modified the file system. I hope our notepad will be here. Okay, I will put also the filter on a process name, so it will be easier to find. Notepad, I will add this filter. Notepad exa, I believe. Okay, and now our test file is here. So as you can see, with just a few filters, we were able to find, I hope you can see it, we were able to find the write that we made. And it's also, the details column contains some interesting information. So for instance, if we, there's this offset and length, it might seem not a very useful thing to know, but I remember when I needed to sort of understand the format of a file, thanks to this offset and length, I was able to locate the header in a file which format I didn't know, just because I saw at which time the tool that I was tracing was producing a data that was interesting for me. So you can always get back and then check the call stack to see, okay, so that was happening from this place, and then reverse it.
We have here file access, network access, registry key access.
Yes.
A lot of different stuff. I remember using it when I was solving problem of certificate signing, because I needed to use kind of, I don't remember, probably it was used for SOAP security to sign a message, and I just cannot configure the library to access the key, and because it was taken from very strange place, and by using it I was able to identify where it is trying to find this key when it ends to try to load it from, and so on and so on. So it is very, very nice to use for such cases. Without that, I would really not know, because it was the internal code of the library, so I couldn't add any logging there. So
yes. We should also mention all the summaries that we have here. So for instance, the file summary, where we can check all the files. So when Konrad, when you probably were looking for those writes, you could have checked either by path or by extension, look for the file which was modified.
Awesome. So we have here the general OS level thing that can be obviously used also in .NET related scenarios. I've used it a few times for sure. By the way, how do you feel running it on production?
I run it on production, and I believe it's really safe to run it in production. And also maybe one remark, when you run it in production and you have filtering, you know what you are looking for, then consider adding the drop filter events. So normally, without this checkbox selected, Procmon will collect all the events. So you will be able to filter them later. But if you know what you are waiting for, then select this one, and all other events will be completely dropped. So for instance, when I remember running Procmon for like a week to find one problem that we had. So awesome. One process which was writing a file, and I knew the path, so I was simply waiting there on that machine with Procmon running, and we found who created that file.
Right. Oh, great. So here we have a process monitor. By the way, do we have, because it is on Windows, do we have something similar on Linux?
Yeah, we have actually a bunch of tools on Linux. I tend to say that STrace is the tool to go to on the command line. Right now, I think that BPF tools that Brendan Gregg published, there are lots of them, and they are extremely powerful. And so I think that on Linux we have several choices, but STrace is the easiest one to use. Also very straightforward. But unfortunately, it's based on the debugging engine, so it's more invasive than Procmon. But on the other hand, it allows tracing everything. So, sorry, not everything, all the syscalls. So STrace can get you more data than Procmon, because all the syscalls that happen in the system can be traced with STrace.
So we have some alternatives on Linux simply.
Yeah.
Great. And as we said, Purview and .NET Trace will be covered during the demo. The very powerful,
in a moment.
More .NET, much more .NET related tools, but we will cover them in a moment. Okay, so another thing is memory dumps, my beloved topic. Like, I'm memory guy, so memory dumps. So maybe I will say a few words and then you will add some more. So memory dump is awesome because you have this possibility to take a process, freeze it at some stage, and then investigate in detail what was inside. Obviously, the typical approach is to make a memory dump on production and then move it to your local machine and then analyze it, because analyzing it on production server is not so super convenient approach, although sometimes there are some problems because those memory dumps can be quite huge. So there are some problems, like maybe there is no enough space on disk for memory dump if the server is fine-tuned and doesn't have huge memory on disk. But still, a memory dump is a pretty easy idea. So we are just having a snapshot of the memory of a given at a given moment, and then we can investigate what was inside, which is obviously everything, because there is the whole process. So if we have enough knowledge, we can take almost everything from it. I even imagine the tool when if you take a memory dump of the kernel of the operating system at the operating system level, you were able to reproduce what windows were and what was the size of the windows and everything. In general, you should know that everything can be taken from the memory dump. So be careful in sharing because every protected data and RODO data, related data, also will be there. Okay, so that's from me. Probably you will.
Yeah, I will only add that I really, when you collect the memory dumps, and I'm not sure how many of you like forensics work, but memory dump analysis is sort of a forensics task. And if you like it, then you will really enjoy it. You can smell the data when you're working with the memory dump, and there is a lot of data usually. It's really, I would say, when you solve a problem from a memory dump, you feel this happiness that you found the cause in a snapshot, on a picture.
Right. This is detectivistic work. Yes. And regarding tools, there is a Procdump that you will show.
Yeah, we will use Procdump in a moment.
We will use Procdump. Recently, there is a .NET, this set of CLI tools for the .NET diagnostics. So we have .NET dump simply as a command that we can use. So it is another set of commands. Obviously, this is 1 hour webinar, so unfortunately, we cannot cover everything. So this is just like of pinpointing things. That there is something like memory dump. We will cover taking memory dump by Procdump in a few seconds. So this is it. Now I believe it's time for the third one type of toolset, let's say, profiling. So we covered debugging, we covered tracing, and we covered memory dumps. And before, maybe I see we have 2 more questions. So let's jump to the questions for a second. Another comparison between distributed tracing and traditional tracing. Any thoughts about that? The role, how is the distributed tracing on comparing it with the traditional one?
It's hard to compare them. I would say that, well, you have the tracing on a particular machine. When it's a distributed tracing, I would say that I wouldn't say. I'm not sure if I understand correctly the question. Is it asking about the role of the distributed tracing in the normal, the tracing that we are talking, the troubleshooting tracing, or?
So maybe Mauricio, maybe you can just add few more words of clarification to the questions. Yeah, rephrase it or so. So we will come back to this question. And another question is about Minidumps. What types of Minidumps we are talking about and generating?
I believe that this question is about if we say Minidump, the Minidump itself has several formats in it. So it could be a full memory dump.
Which is because we have Minidump, which is named full dump.
Yes, exactly. I remember that in the past, I'm not really sure if now any of the tools that we use for creating the memory dumps use the old format of the full memory dump. I feel that right now every tool is using the new mini dump, but the mini dump can contain all the memory pages. So in fact, it is a full memory dump. But it can also, we can with either Procdump or another tool that we use for debugging, or maybe using the WinAPI, we can define which with flags which pages of the memory are interesting for us. So which of them should be included into the memory dump. So for instance, we could create a memory dump only with the call stack pages and some, let's say, private data, or we can create a mini dump with the GC data, which of course requires the GC to be involved in that. So the GC, the heap, sort of heap dump. So I would say that there are many of them, but most of them are either using the WinAPI, so the Minidump API, or using the Dotnet API for collecting the memory dump. I believe that's it, right, Konrad?
Right. I would say that it is pretty misleading that we have this full dump as a type of mini dump, and as you said, the real full dump maybe it's not even existing, but we are still taking them. Like you can take a mini dump, which is just the whole memory of the process. So although it is called mini dump, it is really still gigabytes in size because it contains all the data. And in fact, maybe I'm not correct, but it is a typical approach to use procdump -ma to take a full mini dump.
Yeah, I believe so.
Yeah, so unfortunately, and for me also, it is pretty troublesome sometimes just to pass this dump from the production server to the machine that I will be able to use because it is huge, unfortunately. Okay. Okay, so profiling. A few words about that because we have also a demo to show, so maybe we can shorten it a little and you can just say a few words about profiling.
Yeah, so profiling, I would say that profiling is more invasive than tracing. The reason for that is usually profilers, for instance, the .NET profilers, they are using profiling API, which is usually the case. They do this IL rewriting, so they are sort of hooking the methods, wrapping them.
So we are particularly saying about CLR profiling API, which is special, well-defined standard, how you can plug into the process, and every runtime executing application needs to handle this API.
Yeah, exactly. And that's maybe we can share the screen again. I have a very simple application, the file hash, which is creating file hashes. It's not really important what it's doing. The important thing is that we will trace it, or not trace it, we'll profile it. And to use the profiling API, the .NET profiling API, you need to pick the instrumentation profiler in Visual Studio. I feel I'm not sure, but I feel that it's not yet fully implemented for .NET Core. The reason for that is that if we try to instrument an application that has over to those advanced settings, that has the portable PDB format, the profiler will complain. And the portable PDB format is the default one for now. So you need to first switch to full and then run the instrumentation. But if we start the instrumentation, I have as an argument, I have some bigger file, I believe, I have some database that we will, for which we will collect the profiling data. So if I run it now under the profiler, so here I will start, and we'll start the application. I will also start Process Hacker. So that's another great tool, by the way. And I find the, okay, not now. I was a little bit too late once again, sorry. I'm not really interested in that report right now. I just want to collect the instrumentation data. So I start file hash. Okay, now Process Hacker, file. Okay, now I got it. So the way how we can learn that the process is being profiled is by checking its environment variable. So as I said, we can do that with Process Hacker if there's an environment tab in the properties, and here we can see that the Visual Studio under the hood is using the Core CLR profiler, and the GUID here is the identifier of the profiler engine. So the engine that Visual Studio uses to profile an application. And this ID, we can find it in the registry. If I go to registry, if you have ever played with COM API, that's something that exists in Windows in so many places. A lot of things are implemented using the COM interfaces, even .NET itself. And I will show, if during the demo, I will show you a funny thing, how we can learn that it's based on COM. But we can, all those class identifiers, that's how it's called, can be found in the registry. And I have the bookmark here for this particular as you can see for this ID. And if we go here and pick in proc server, that's the server that will handle the request, and we can here find the exact path of the engine. So the where the profiler is implemented, which DLL is it. And if I copy it, maybe not like that, but like that. That's the folder for the profiler. So this DLL contains the engine of the profiler for Visual Studio. And unfortunately, it's not it's native, so we can't easily decompile it. We need some disassembler to do that. But
so here we can just yes, we have this evidence that indeed Visual Studio itself is using CLR profiling API to make this instrumentation. And by the way, we can use our own, right? So we can write our own DLL implementing this API, probably doing bad stuff because it is really hard to implement it, but still there is only GUID, one set as a environment variable for a process, and then it is starting to use its own profiling.
Yeah,
and that's very nice. And we will cover that in the course, how to do something like that, or
yeah,
just
we'll be covering instrumentation from Visual Studio. We'll talk about that. Maybe not necessarily the CLR profiler API.
right.
I guess
It's super low level stuff.
Yeah, it's a vast topic.
Right.
Yeah.
Matt Warren is probably one of the guys leading from it.
Yeah, he probably wrote about it.
Right. Okay, so we have covered profiling, and then we have this non-invasive one, invasive one. Everything of that will be covered in the course. Sorry for recalling this all the time, but this is only 1 hour, and I currently see it will be longer than 1 hour. But let's move to the demo now, because we have demo to show something of the topics covered, like tracing, memory dumps. So the scene is yours. Now you have more demo time for showing us all those pieces working together to solve some specific .NET related problem. And just before we will go to that, we have one more question.
Oh, okay.
So .NET API, because we were covering various tools, saying about tracing and dumps. So I understand this question as whether we are talking about something available from the console, or whether we can use programmatical API to access the same functionality.
If I understand that correctly, then yes, we can access this API, and the profiling API that we mentioned is a programmatic API. So it's an API for developers of the internal tools. Same with the event pipes that we will also use in the .NET Trace. So even the source code of the .NET Trace is available. So we can always check which API they are using from the .NET API. And as a .NET API, I would say that it's the CLR API. That's what we.
But in general, a lot of things that we will be showing, we are discussing, and in general, Microsoft is providing has some programmatical API. So tracing all this stuff related to things that then you can analyze with Purview or in Visual Studio, it is possible to control from C#, for example. Even you can create this tracing for your own session, for your own process, right? Or some external process. It all depends. Everything is possible. Okay, so while waiting for another questions, let's move to the demo now.
Okay.
I'm just giving you the screen again.
Okay. So just as an example of an application which is breaking, I used a little modified version of an application that is available in the ASP.NET Core documentation. It's just a list of movies that have some price, and it's not really important. The data is stored in SQL Server database, and we can add a new movie here. So let's add Pulp Fiction, for example, and I believe it's a crime movie, and we'll add it, and then we'll create a new one with a longer title that I have here. It's a Kubrick film, very good one. Let's try to save it. That's a comedy. And when trying to save it, we receive an error. So in the configuration, I disabled. It's a release build. I also disabled the development environment. So we are not seeing the exception here. Of course, we do not want in the not development environment. We do not want to share the exception information, and we do not have any special error page. So it's just the default one from ASP.NET. But what's important is that I'm using the Kestrel web server, and I have its default console. So I have the console logger that I will cover in a moment. But we can see here that the fail log was recorded, and we have all the details. We can see that it's the async. It was the async call, and somewhere here, if we look deeper into the trace, we will find the original exception, which is that SQL exception that string or binary data would be truncated. And of course, our example is very simple because you probably know exactly what is the problem here. But by using this exception, I wanted to show you the general way how you can solve these problems and collect more information about them. So we are in this identification phase now. And from the log, we already see the last. That's really cool that Entity Framework is also logging to this console using the iLogger interface. And we can find the query, the exact SQL query which was failing, and we can find some information about the parameters, but we can't find their values. Of course, it is possible to log the values of the parameters in Entity Framework, but I suppose no one is doing that in the production because of few reasons. One of them is probably confidentiality. We do not want to have the exact data stored in our log, so we need to have it sanitized. So we do not need to sanitize it. So in our example, so in this kind of an error, when we do not know really which column was the problem and which data, it would be great to know these parameters. So we'll try to find them during the diagnostics session that we'll have now. But before we switch to that, let's focus for a moment on this logging infrastructure. So if you're
just to jump with something, so maybe some DB admins now would say, or maybe SQL related devs say that maybe you could enable logging on the DB side. But obviously, this is again maybe a huge overhead, right? So
yeah, if you're using the SQL profiler, for example, that's a big overhead. If you are using the events from SQL, that's like ETW, but still you require DBA to do that, and you will require the access to the database to enable this tracing session. So
it is not so trivial that let's enable and see it. Especially it is not so often, so you would like to have it and wait for it for, I don't know, for half an hour, for example.
Yeah, exactly. Especially in big companies where those teams are not together, but you need to create a ticket and so on. But moving back to the logging for ASP.NET, if you are an ASP.NET developer, you know this upsettings file when we can we can define the namespaces and their level for which we are setting the log level. So here I have Microsoft logs or Microsoft logs, except for the hosting lifetime, will have the warning level, and everything else will have information level. That's I think that's the default for the production right now. And you probably also are adding a new your own loggers like Serilog or nlog in the configure logging section. I'm using the default ones. So, and the default ones, if we look into ASP.NET source code, there is a webhost CS file where we have the create default builder method. And this create default builder has the default logging settings for ASP.NET Core. And as we can see, we have very interesting options enabled here. And those are really cool options. We'll cover them in a moment. Because we have activity tracking and those activities are very useful when diagnosing. We also have the console logger, so the one we could see in the console window of the application. It's defined here. We also have a debug logger that will also see this log in a moment. And this one is an extremely powerful logger, which is event source logger. And I would like to focus on this logger now because, well, in our case, so in the movies application case, we can always, even when the application is running in the production, we can always try to change this value to trace. But of course, that will require the reload of the configuration. that will affect all the requests that are coming. Also, if you are sending those logs to some other storage, immediately you will have a much bigger load. So I would say that it's not very safe to change the log settings in the production in this way. Another way to access the trace information, so all the logs that we can, all the context of the problem, is by using a special logger, the event source logger that I just show you here. So the one that is added automatically. Its name is logging event source. It's in the ASP.NET Core source code, and as you can see, it has a really long comment above, which this comment explains how to enable some filtering on it, but we won't really use the filtering. I will show you the simplest way to use it, and then you will have a look how many information it contains. And I mean, I just copied the name of it. As you can see, it inherits from the event source class. This class is a special class that if you want to create custom traces in your application, then inherit from event source. Another one, I will cover it in a moment, is the diagnostic source. But logging event source is just an example of a custom event source. So something that will produce events, will collect, and then a logger that we could use in our application to write events. And the most important part of this class are keywords, and keywords here define the way how our logs will be serialized. So if we pick for our example, I will pick the formatted message, but we could as well use JSON message, in which case the logs will be sent in text, of course, but as a JSON object. So they will be serialized to JSON, but I will use the keyword number 4. And I will use PowerShell. We will use the .NET Trace tool that we mentioned. And first I need to know the PID of my process. And I will run .NET Trace collect P, so the process ID, and then providers. And here, okay, it just cleared I will use the name that we have here, and then the 0.4 keyword. And I have the trace running right now. I'll go back to the application and we will reproduce the error. So we will resend the bad data. The exception happened again, and I'm stopping the trace. And I will you can open the net trace file in Visual Studio, and it looks that they started working on supporting those trace files. Unfortunately, I believe it's still a preview or something like that, because it can show only 20,000 events. So that's not much when we are talking about traces. And additionally, it runs pretty slow. So at least for now, I definitely recommend using Purview for opening the net trace file. And nettrace this logging event source, it's simply events. So we do not have any other views that we need to check. We just open the events window and then select the Microsoft extensions logging sources. So
yes, I select just while you are showing this, I will just add that Purview is the tool for tracing and many diagnostics things. If you don't know Purview, it is written by .NET developers for .NET developers mostly. So it is really, even it looks scary, it looks like that because it was written by developers. It is open source, it is free. It has super powerful capabilities, although you really need to get used to it and this learning curve is a little bit hard. But we are also covering this tool, right? I believe you are showing and using this tool pretty often. I'm also using this tool really often on real-world diagnostics because it just works, although it looks like it looks.
Yeah, and you can always have the time travel when you open Purview. You can feel like in 90s.
Yes. What I really like in this tool that almost every label is a help. So all these blue
Yes,
labels
exactly.
are just links to help. So
We
there is a
can
lot
click
of
and
reading.
immediately we can see the help that describes. That's really awesome. I saw that only, I mean, this detailed help I saw also in WinDBG. It has also a very great help file. Unfortunately, not really updated anymore, but
Right.
it has lots of information. So moving back to the events view that we see here, and those logging, as you can see, we have a bunch of the events. So we have activities logged and also the formatted message so the format that I chose, the keyword for formatted message. And if I scroll a bit here, a bit further, you can see that we have all the logger names. So the logger names that you normally have in the trace, you have them here, and you also have the formatted message. And this formatted message is exactly the same message that you would receive if you enable the trace logging here. So I didn't specify the level, so automatically it's trace for event pipes. For the technology that .NET Trace is using. So without changing any configuration of the file, of the application is still running with the same old config file. We have all the tracing events. So for a moment, for the time when we were reproducing the error, we collected a lot of other informations which can help us diagnose the problem.
So it is like enabling trace level for the time of gathering this session with the help of this tool. Right?
Yes, exactly. Additionally, we have this ID column and arguments column that if we select them and add them, you will see that those are attached only to the activity traces. And those activity traces, I believe, are pretty powerful because they will show you, they group the events into activities. And of course, we have the request ID, which is used in the other logs, but we also have a sort of a scope of for instance, request. So here we have an activity ID 39, and if we scroll down, we'll see that the request, we have the activity stop, and we have the activity for it. And if I add the duration in milliseconds, we will also see how long a given activity lasted. So that's also a very useful information to find. And obviously, ASP.NET also groups inside the given activity. We have, for instance, actions when you see that there is a movies create, but then when the error happens, then there's another action created for that, the error action. So it's a really good way to also learn from the trace how much time a request took or an action. A request or an action or another connection, how long it lasted and whether it finished or not. And
so questions before you move on. The very first thing is always overhead, because we are talking here about production. Can I safely turn it on production?
Yes, that's one of the really great things about .NET Trace is that it's using event pipes for that's a, I don't know how to call it, a component of .NET Framework, which allows tracing the CLR. And I believe it is made for production. So it's really this type of trace that I collected here is not really invasive. It's sending the data to a tracer, and once when we are attaching. It runs only when we are attached. So only for this period of time when I had the trace running, we were collecting those events, and we were actually not saving them in the application itself, but we were just piping them to the trace tool. So it was the .NET Trace that saved them to the disk drive. And for the application, it was only the matter of sending the data to a named pipe on Windows. So that's really a non-invasive way of collecting the traces.
So it is designed for that simply.
Yes,
and
exactly.
Another thing is that there was a very short time when all events you were presenting, there was this has stack true attribute. So not only we have all information about all those events, but we have also stack trace for them, right?
Yes,
So
yes,
we can
and we
take,
can access. Yeah, sorry, Konrad. I just wanted to say that we can access the call stack by selecting the time milliseconds column and then pressing Alt S, or I'm so used to those, I just click them. So open any stacks, and that will show the call stack of a given event. And Purview matches the call stack by timestamps. So if there was another event that happened at the same time, we'll see both of them, but then we need to look at the process ID and just expand the one that is interesting for us. So that's something that you need to remember about.
Great.
We can move on, or there are any?
Yes.
Okay. So as you can see, we have this. We can, without modifying the application configuration, we can access the trace logs. But that was the first way of getting the logs. I don't need to mention that. Maybe I should, but those logs, even if we have this tracing level enabled, we still, for our case, it won't help us, because the entity framework still, although we have the logs, and for instance, we see when the connection was open, when the transaction was starting. So for other types of issues, this could be enough and will be very valuable. But for our case, we still see the parameters without values, and we just see question marks and the same log that we received in the exception. So it's still not very useful for our case, but generally, I believe it's a great way of collecting ASP.NET traces. And if those are not enough to diagnose the problem, there is even a more detailed trace, and it's called the diagnostic source. And if we go to the generic web host builder, so the web host builder that is created by default, we can find here a listener, diagnostics listener, and diagnostics source, which is, as you can see, it's registered in the services, so those services are available. There is an interesting review comment that is probably bad to do that in this way, but I believe that they might, it will be probably moved to some other place, but this functionality will still work, because when you look into the source code of either .NET runtime libraries or ASP.NET Core, you will see that at least I see that there's a switch from the event source logging. So instead of using the event source directly, they are rather using the diagnostic source and diagnostic listener. And just for a brief moment, I will make a digression. So we'll see what those things are about. And let me only go to I created a picture that shows how those things are related. And in a moment, I will show you how to use them. So we have the diagnostic source and we have a diagnostic listeners. Those names are a bit unfortunate because diagnostic listener implements diagnostic source. And diagnostic source is, I would say that's the logger. So we use diagnostic source to log stuff. So to send logs, and ASP.NET is using diagnostic source. The entity framework core is using diagnostic source, and we can also create our own diagnostic sources. Then we have the diagnostic listener, which is it implements iObservable. So if you are familiar with reactive extensions, then you will know that iObservable is a class that we can subscribe to, and it will send us events. And maybe I will stop here and cover that in just a bit. So we have those two. So how we can use them? I created a very small application as to show you this quite powerful API. I will open the project here. And we have a small console application, and we create a diagnostic source, and that's, I know that it looks strange because we are creating diagnostic listener, and in fact it's diagnostic source, but it's just the way it is. And we give it a name .NETOS test logger, And to use it, you simply write a log. And what's really great about it is that we can here log any object we want. So it does not put any constraint on us what type of objects we can log. So that's the reason why we do, when we create those objects, those log objects, it's pretty well. It's advised. It's advised to put a logger is enabled command before creating an object, just to do not create objects unnecessarily and add some work for the GC. So after we check that the start log is enabled, we are writing a new object to it. And look that we do not, here we don't really care how it's serialized, whether it's serialized or not. We are creating a plain object and we forget about it. So we create an object and attach it to a given event. And then in a moment, I will show you how to retrieve this event externally. But if we want to collect events also in our application, so we can implement our in-house logger. That's how, or maybe rather in-process logger. And for that, we have an API in the diagnostic listener. There is a static property, all listeners, to which we can subscribe. So that's the subscribe API is a part of iObservable, so reactive extensions. And the first, if we subscribe to all listeners, then we will receive notifications about listeners that were registered in our process. So for instance, here, we will receive a listener.netos test logger because we are creating it in the log in the file. But if it's an ASP.NET core application, for example, then we will receive if we subscribe to the all listeners observable, then we will here receive information about listeners such as ASP.NET Core or Entity Framework Core, and then we can listen to their events and receive the whole objects such as request object, and then collect data from them, extract some information. That's a really powerful technique. And so I will run the application to show you what happens. As you can see, we are subscribing to this listener, to our test logger listener, and we simply dump to the console the key and the value. So the key is the event name, and the value is the object that we created here. And as you can see, before the hello world, before the console right here, we have the print from our subscription. So that was the digression how this thing works, but let's move on. So how it can help us in our case. There is a sort of a bridge that my .NET developers created. It's called diagnostic source event source. And this diagnostic source event source is an event source, as the name suggests. So it inherits from event source, but it has all the serialization logic, and you don't need to add any additional NuGets to your application. It's just in the .NET Framework runtime, and it's ready for you to use. So when we attach to a process with .NET Trace or ETW or LTTNG, then we will immediately enable this this bridge, and it will start serializing events to the text format. So maybe let's do that for our example. And I need to also mention that in the .NET Runtime repository, there is a whole user's guide for diagnostic source. As you can see, it's not an easy read and a small one, but after you see how many events you can extract from this diagnostic source bridge, or diagnostic source actually, I guess that you might want to read it. It's really interesting this whole idea is really interesting. And we also have a lot of comments in the diagnostic source event source that explain how to format the strings to filter the events. We'll use one of the very simple filters in an example in a moment. But for now, let's trace again our application, but this time instead of using actually, we can use the previous one, so we can't use this one, and we will also add the diagnostic source provider. I need to recall its name. Its .NET name. It will be in the snippets file. Sorry, not this one. I need the bridge. That's the name I want. So again, we will copy this name and we will paste it into the console. I would not provide any keywords for now. I will just trace everything. So with just enabling the name, we are automatically tracing all the events for this diagnostic source. So let's do that, and let's rerun the error. Let's reproduce the error. We should have the trace. Again, we will open it with purview. So the logic is exactly the same. Sorry, the steps are exactly the same. Trace net trace, we open events, and here you can see that we have a new logger, diagnostic source event, diagnostic source message, and new diagnostic listeners. Those last two are, I would say, meta events. So, for instance, the message simply says that the diagnostic source enabled everything. There were no filtering enabled, and here is the. If you recall this all listeners subscribe, that's exactly what is happening here. So here we have an information about all the diagnostic listeners that were that were registered in our application. I don't know why SQL client registered 3 times, but the other ones, so ASP.NET Core and Entity Framework Core, we see that we also have them here. So if there were any other loggers, diagnostic listeners, then we will also see them here. And then if we look into the event, into the payload, we can see that we have the event name and we have arguments. And the arguments is the most interesting part here, because arguments contain all the properties of an object. And by just looking at what we see here, you will see that the bridge, the diagnostic source, event source, does not serialize complex objects. It can serialize only integers and strings and GUIDs and date times. So all those types of properties, actually all those types. But it shows you what type of object is here. So by simply looking at that, we can I will show you in a moment, by using filtering options, we can extract a property of this field. So as an example, I will pick the SQL client diagnostic listener. It will be somewhere here, for instance, write command error. Here is write command before. Maybe this event is interesting. We'll focus on this one. So we'll use the SQL client diagnostic listener, the write command buffer before. And if we look at the arguments, we'll see that we have some operation, which is a string. Then we have another string. Then we have a connection ID, which is probably a GUID. And we have the command object, which is, as you can see, it's not serialized. It's just an information that's it's of a SQL command type. And we know that SQL command has a property named command text. So let's try to extract this property. Although I know Entity Framework logged it for us, but I still want to use this property. So for that, as you will see, the command is a little bit more complex. I will copy it from my cheat sheet. And I will explain it, what it's doing. So again, we have the .NET trace collect, then we have the providers. And here, as you can see, I'm using, again, the Microsoft Diagnostics diagnostic source, but then I'm also specifying all possible keywords. Then the verbosity level is set to 5, so verbose events. And here happens the magic, because we have a special keyword, filter and payload specification. And by using this keyword, we can say that, okay, give me events from SQL client diagnostic listener, then give me this particular event. So SQL client write command before, and then we have a minus, which says that we are not interested in any other properties except for command. And from command, give me command text. And the PID, I need to copy it, and let's collect the trace again. Reproduce the error. So I will go back here, resend the the request, stop the trace, and again, I will open it in purview. I should have the command somewhere before. And if we look now into the events, we see that there's a lot less of them because we decided that only the SQL client events are interesting for us. And look what we have as a payload for the arguments. We have only the command text, and the command text contains the command text that we have. There are some more settings that we can use, and one of those that I tried using. You might be hearing something. Konrad, can you hear it? Or
Mystic clicks. Yeah, a little bit,
yes,
but not so noisy.
Okay. So let's move on. Fortunately, that's
technical issues with the camera, right?
Yeah. Sorry for that.
It's counted. It starts to make some strange noises from time to time.
Yeah, I maybe I will tap it or something. Okay, for now I will just keep on talking. It's fortunately we are reaching almost the end. So we have the command, and I was thinking that maybe by using some more advanced filtering, we can extract the properties. So there is a special enumerate keyword that allows you to enumerate. If there's an object which is of type IEnumerable, then we can enumerate it. But unfortunately, it works only on this level. So only if the whole object was enumerable, then that will work. But if I tried to enumerate through the properties, that didn't work. I hope it will work at some time in the future. But for now,
it looks like they are creating kind of query language for this file. So we can expect more and more features, because it sounds like super convenient thing to have all the level of enumerations and in filtering. So do you know if there is any issue about that, or we should just create one?
There is one about parsing in one of the Linux shells, because the apostrophes and all those semicolons and colons, they are problematic. And I saw that there's an idea to enable loading all this filtering section from the configuration file, and that would solve all the problems with the formatting. But there is no issue for the enumerable. So something
because in general, this is something pretty new, right? It is not something existing for years, but it is something recently added, and we for sure can expect more and more things to come.
Yeah, I think so. Yeah, exactly. So okay, but still, as we saw, we do not have the parameters. So let's try another way which we mentioned during the presentation, which is let's maybe create a memory dump. So we will use procdump for that, and I will show you a little trick with procdump that I always use. I mean, maybe not always, because when you didn't trace before, I mean, when the only thing that you know is the bug, then sometimes it's worth first creating run procdump in a sort of a logger way. And for that, we will use the E option is for the exception, because we would like to trigger a memory dump when the exception happens. One here is that we are interested in at first chance exceptions, and first chance exceptions are they happen at the moment when we throw an exception. So not when we catch an exception, but when we throw it. So every rethrow will also be named first chance exception. And L is for logger, so we will enable a debug log, and then we can set a filter. And filter is for it's a help for us to create a memory dump for a very specific exception. So here we can type an exception name. I won't do that now, because when I do not have .NET Trace, when I do not have information about what's the exception time, I simply type X several times, so I know that this exception does not really exist. And And then you simply write the PID of the, MA, which is for the full memory dump, and the PID of a process. So we have it here, and let's run procdump in a listening mode. When procdump starts, it shows you what type of monitor is enabled. So here we can see that first chance and unhandled. And obviously unhandled won't happen because it's an ASP.NET core, and it does not terminate when our code throws an exception. And it also shows the include filter. So we include every exception with XXXX. And again, I will rerun the request, and as you could see, it ran a bit slower, and it's just because procdump internally is using a debugger. It's a lightweight debugger, but it's still a debugger. So it has some impact on the application. Fortunately, once it collects the dump, it immediately detaches from the application. But as you can see, it logged the first chance exception, so Microsoft SQL exception. And you see this funny number that when I mentioned the COM technology and all this history of .NET, I will open a hex editor, create a new file, and I will show you what this, okay, one moment. Okay, edit paste from, and we'll paste from hex text. As you can see, this funny looking hex, which we saw, E043, is in fact something like here. So here we see COM, and that's the history of .NET. It means that, well, it was based on COM, and we can still see it somewhere. Even if it's .NET Core, we still see that it has the same signature for an error. So that's a little bit of history. But another thing that I wanted to show you is that, look, that we also received the debug string. So the logger that we saw in the generic web host, we see that a procdump is also showing the debug logs. So if we attach any debugger, actually not only Procmon, but also if we were attaching Visual Studio, then the debug log will, the ASP.NET application will send logs to the debug log. Those will be the same logs as our application is sending. So in our case, it will be only this error. So basically, we see the same data as in the application, but it's just worth to know that it is there. So once we are sure that we have this SQL exception, let's create the actual dump for it. I pressed Ctrl+C or in PowerShell Ctrl+break to stop procdump. And here I will, in the filter name, I will paste the SQL exception. So let's create the actual memory dump when the exception happens. So I will, again, send the issue, reproduce the problem. As we can see, we have the memory dump created. It's time to open it in Visual Studio. So let's open it, Visual Studio. And we'll use the managed engine for debug with managed only, because that's the managed application. So we can pick it, and we know that the problem happens in the managed code. We do not need to access the native code. And what's great about first chance exceptions is that the call stack is not unwind. So we can, by clicking on the frames, call stack frames, we can switch between them and examine the state of the application. And that's really great, because if we scroll down and find a SQL command, any actually frame with a SQL command, we will have in the locals window, we'll see this object, and that's a SQL command. And here we can, as you can see, we can access all its properties. So, and nothing is stopping us. We have a lot of time because, well, we are on our local machine. At least if the production is not on fire, then we can safely examine the problem here. So we have the command text, but now we also have the parameters. And if we access them, the inner list, we will see that we have all the parameters. And here is the problematic one, so the one that the long string that we had. So we can rerun the SQL command, put the parameters that we just restored, and be sure which of the parameters caused the problem.
And everything without WinDBG, right?
Yeah, even without WinDBG, exactly.
Visual Studio is doing a great job here.
Yeah, yeah.
And
Exactly.
you mentioned that the overhead is not, there is some overhead, but would you be afraid of using it on production, or you can just use it with this filtering and wait for this exception few minutes?
I must say that I tend to prefer traces right now, also as you said, Konrad, previously, but I use Procmon in the production, and it's pretty safe. I mean, I know it's debugger, it will slow down the application a bit, but
it's not 2-3 times slower, right? It is.
yeah, exactly. It's not a full weight debugger like Visual Studio. It's not. It does not have any breakpoints. It does not create any breakpoints. It simply waits for an events like the debug log or the exception log. So that's something that.
So we can use it to wait for this specific exception on production for a few minutes or maybe even 1 hour. I even remember using it on production like that. So
I use it too.
Yeah, just to provide the command line to the admins and just run it and wait for the dump to be created.
Yeah, it's usually safer to slow the application a bit and then have all the information about the issue than do nothing.
Just only please remember about the hard disk space.
Yeah,
because
exactly.
It may be pretty big dump which will stop everything if it's not enough.
In that case, you might try changing the flag here. Instead of using the full memory dump, maybe use only private pages and check if you can access the information that you need. So if you can open the dump and find
and the story about the proc dump on Linux, because as far as I remember, there is a version on it recently.
Yeah, there is, but unfortunately, it's lacking triggers on exceptions. And I believe that it's not really a problem with proc dump itself, but with Linux, because as far as I remember, Linux does not have this special event for first chance, so it won't notify the debugger when we throw an exception in the application. Instead, it will just we will receive an event only on the second chance, so unhandled actually exception. And so I'm not really surprised that the proc dump for Linux does not support this trigger. I hope that they will be at some point in time they will add it to .NET dump, because I guess that's the best place for it to be cross-platform.
Sure. Great. It was pretty awesome. So is that does it concludes the demo?
Yeah, that's it for today. Thank you.
So we have a lot of tools being presented here. Still, it is the top of the iceberg. I'm feeling that, but it is at least showing some data about around and some demos around Purview. .NET Trace, .NET Dump was not used, but it could be also used, and so on and so on. So really, really nice stuff. We have 2 questions. Just instead of me talking, let's see those. So the first one is about Docker. How to run tools, .NET tools inside a Docker.
Actually, I don't remember which repository, whether it's .NET Diagnostics or .NET Runtime. They have a really nice document describing how to attach a separate container which will have the .NET tools there. Of course, there's a need to have the connection between the containers, but everything is explained in that documentation. So I would just ask you to go to the documentation for the diagnostics tools and check it there. They have the whole all the steps explained in the doc.
And by the way, previous week we had this webinar with Mark Downey and Chris that they were showing us .NET Monitor, which can be installed as a sidecar for in Kubernetes, for example, which is doing exactly that, exposing REST API for those comments. So you can create trace just by calling some specific URL and then getting all this data. Because this sidecar container is connected via temporary file system with this original Docker image, as far as I remember. So .NET Monitor is the one thing that you can look for, and the documentation mentioned by Sebastian also. And I believe it is so important that we are going to cover it in our course, right? Because Linux, Docker is the thing that people are using more and more, so we would really like to explain that. And another question is, and automatically uploading.
So after we created a dump, how to automate the creation of a dump itself? If it's about automating the dump, creation of a dump, well, it's possible, but I believe that you create a dump only when you have the diagnostics case. So when you need to troubleshoot something, then you set the triggers. I would not recommend running procdump all the time. But if this question is about if it's possible from the application itself to create the memory dump, it is possible, but also I'm not sure if anyone is doing that. I mean, okay, in the Windows application, I saw that they were implementing the not really engine, but the logic for creating a memory dump. It's simply a Windows method that you need to call with some parameters. So it is certainly possible to do that from the application itself. And so you could, if you have a Windows application and when it breaks, you would like to create a memory dump, then you could do that from the application itself. But for that purpose, I would actually recommend using Windows error reporting. They have a really great API, and you can register your application. You can register you as a publisher of an application and access the dumps that are sent, because in fact Windows error reporting is creating a memory dumps where something happens. Sorry for that. And so we can create the memory dump, and we can use Windows error reporting to create a memory dump.
Awesome. Okay, so if you have any more questions, please, we have few more minutes. I wouldn't say we are above the planned time because we didn't have any super strict time planned. We would like to show you just the data and the whole demo and all the stuff that we have covered, so I'm happy that we did it. All this is because of this .NET Diagnostic Expert course that we are having now on pre-sale, so if you like it, just go to the diagnosticsexpert.com site, look around what we are giving there. We have this promotional price now, so if you are interested, if you need to know all this stuff, and I believe really a lot of people should know all this stuff. Now I hope you see that Sebastian is really debugging ninja. It was really just a small piece of the thing that he is able to show, obviously because of the timing reasons. So just look around at this diagnostics expert. We have also those 3 awesome mentors, which we will have live webinars with them during the course. All will be in the form of 11 weeks of the materials, that it is really covering all the possibilities that you can meet. And we are concentrating there on mostly on the production things, right? Obviously, you are also covering the debugging stuff, how the debugger works and all these things, because it is super nice to know and it is a kind of fundamental knowledge. But this is more about development, and this is course about diagnostics. So all this stuff that is a little bit above the simple breakpoint in the debugger will be covered there. Okay, so just look around at the site, and we have few more minutes because we are really almost 2 hours now, so I will just skip through the questions whether I didn't miss anything. I don't see any more questions. There was one thing, one side note, more maybe not the question, about the Entity Framework Core providers. So it is not a question. So thank you for pointing this out. Obviously, it has multiple levels of control because it is pretty huge machine. And just to be clear, obviously, this example was about showing you kind of problem that you can meet to, but it was more about showing the process and the available tools, not the problem of the itself. So maybe something can be solved sometimes with the help of, for example, entity framework, or maybe not, but it all depends on the issue. In the end, from my experience, typically it ends in purview or a memory dump. That's the sad truth that I know from my experience. I don't know what's your experience at that, but this is my experience.
Very similar.
Yeah. And no matter how sophisticated application performance monitoring tools we have installed on the machine, on production, it really very often ends with some memory dump that we need to analyze or some trace that we need to configure, gather, and analyze. So this is a very, very nice practical knowledge. Okay, we don't have any more questions. So maybe you have and want to add something at the very end, any kind of, I don't know, more insight, some super good general advice, or anything.
No, I would only say that it's really worth looking under the hood. So if you are using some libraries, if you are, or actually when you are using .NET, sometimes just have a look. Everything is not, maybe not everything, but most of the things are open sourced. We have these assemblers. We can check what is happening in the application. So whenever you're developing or using a library, even if it's not generating problems, just have a look how it's built. If you have pose the questions inside your head and then look around and find interesting bits in the libraries and in framework itself. For instance, I discovered when working with reactive extensions and observables, I discovered that I was wondering how the observable buffer works, so how they buffer the events. And when I look under the hood, I saw that, oh, they are using the queue class. And then when I looked at the queue class, I saw that, whoa, when the queue is not growing, it is so fast because the array is never they have a very interesting way how they move head and tail pointers inside the array. So you can, even by wondering how it's built, you will learn a lot of interesting tricks how smart people created in libraries and frameworks.
Absolutely. So that's why we like to dig into things, not only exactly how to use them. That's the truth about everything. Right. So thank you very much. We don't have any more questions. I'm super happy that we had this webinar. Just as a kind of reminder, we have another webinar on Friday about CPU profiling because we skipped it a little. And this webinar on Friday at the same time, 7 p.m. Central European time, it will be about CPU profiling, how you can dig into what's inside CPU, what takes the CPU, in fact, in your process and everything around that in .NET, obviously. Okay, so not prolonging anymore because people want to sleep probably. Thank you for being with us. Thank you for all the questions and see you next time on Friday, I hope, or maybe somewhere else. Bye and have a good night or day, depending on which time zone you are. Bye.
Yeah, exactly. Bye.